Welcome back, everybody. The humble platformer, a much-loved genre for many and an entry point for some, offering a comfortable experience that gently eases players into its more difficult challenges. One way to ramp up the difficulty is through the use of moving platforms to test what players have learnt that require good timing, precision, and patience to navigate. So, let's have a look at creating our own moving platforms in Unity. Let's crack on. Here I have a simple scene set up where our little character Oakley would like to make his way from the bottom to the top. But unfortunately for Oakley, he can't jump. So let's help him get on his way by making these platforms move horizontally and vertically using sine waves. For more information on sine waves, I covered them in more detail in a previous video, part 19 of the 2D Retro Platformer series, so please do check that out if you wish. When you're all up to speed, let's go ahead and create a new C# script called Sine Movement and attach it to our platforms like so, and open it up. First, the variables. We are going to want two vector 2s, the first being a start position, and the next being a move position for the platforms. Then we want the platforms to move at a certain speed, or in this case, we will call it a move frequency. So create a public float move frequency, and likewise a public float for move distance, how far in units we want them to move. We also want to determine whether this platform is going to move horizontally or vertically, so we will use a bool to control that, simply called isHorizontal. With those in place, in the start method, let's punch in a reference for the start position. So our start position will equal the current transform.position of the platforms. Now, in the update, let's create an if statement using the bool if is horizontal. Then inside, let's state that the move position.x equals start position.x plus, and this is where the sine function comes into it, mathf.sine inside the brackets time.time multiplied by the frequency, the speed we want it to move. Then we multiply that by the move distance. So this will take care of all the movement along the x-axis for horizontal. Then we want to update the position of the platform. Therefore, transform.position equals a new vector 2, our move position.x, and of course we still want to reference the y value, so whatever that is, transform.position.y. Of course, this is all relevant if we want the platform to move horizontally. If it's not, and we want to go vertically, all we have to do underneath is say else. Then inside the brackets, we can copy this information, just like so, and change the axis we want to move. So move position.x becomes y, start position.x becomes y. This can remain the same. Then all we have to do is update the position by swapping these values around. So instead of move position.x, it'll be the transform.position.x and then the move position.y, just like so. Okay, let's hit save, head back into Unity. Now we can get the platforms moving. Select your horizontal platform, make sure to click is horizontal, and for move frequency, I think 1 is smooth enough. To find out your move distance, select your platform and hold down Control as you move it, and it will snap for each unit. So that was a value of 2 there, 1, 2. So I want my move distance to be 2, either side, just like so. For the vertical, of course, it's not horizontal, so we leave that unchecked. Once again, I'll give it a value of 1. And my distance here is about 3.5. so I'll go 3.5. Then hit play, see how that looks. There we go, that's looking quite smooth. Come on, Oakley, let's go. However, you will notice we're not sticking to the platform. This can cause lots of issues such as slipping and falling to our death. We want to avoid this at all costs, so there is a simple solution to this. What we will do is when the player makes contact with the platform, we will make the player a child game object at the platform. The platform will become the parent. Therefore, wherever the platform moves, so too will the player. And the player can still move independently too. To demonstrate, I will show you a common method I've seen many people do, which does work, however, causes more problems than it solves. I've created a parent to platform script here that I would apply to my platforms, and the script is pretty straightforward. As you can see here, we have a private void on collision enter 2D, collision 2D other, and a private void on collision exit 2D, collision 2D other. When our player collider makes contact with the collider of the platform, then the other.transform, so the player, set parent, and that parent will be that of the platform, this.transform. When our colliders are no longer touching, they exit each other, then we will set that parent as null, so there's no parent to the player. It's back to normal. The reason this causes more problems than it solves is as follows. We can make our way along, and you'll notice when we touch this platform, the player is now a child of the platform. Then, when we step off, if we touch any part of the collider, we get stuck to it. We become the child no matter where we're making contact. This is undesirable, so let's create a much cleaner, more accurate system using a ground checker, which we've used before in our platform series. So, on your player, create a new game object called ground detector and simply place it at the bottom of your character's feet like so. Then go ahead and open up your player controller script. Just like we did in the platformer series, we are going to use the same variables such as a public bool, which we will call grounded, to detect whether we are grounded or not. We also want a public layer mask that we will call ground, so we know that the detector is interacting with objects on that ground layer, which we will assign shortly. We also want a public transform for that ground detector object we placed at the feet of our character, and we also want to give it a radius. So we'll have a public float ground detector radius. Once you've got your variables in place, let's go and create a void called ground detector. So how is the ground detector going to work? Well, whatever game object the ground detector is overlapping or making contact with, we will then get the information of that object to determine whether we're stood on a platform or not. To do that, we will create an array of collider 2Ds. So we'll create a collider 2D array called colliders, and the detector will function using physics 2D. So we use physics 2D dot overlap circle all, so it will get the information of all the colliders it's overlapping, because sometimes you might be colliding with more than one at the same time. Then in the brackets, we need a reference for the ground detector dot position, and we also want the units for the radius, the size we want it to be, ground detector dot radius, and then lastly, the layer we want to detect. That, of course, will be that layer mask of ground. Before we continue, I'd like to explain why we've gone for an array here. So like I said before, we might be stood on more than one objects at the same time. Both of the colliders from those objects will get added to that array. Of those objects, we will then search through that array looking for if we're on a platform or not. But regardless, we do want to be grounded. And how do we know we're grounded? Well, so long as we're making contact with the ground, the array will have at least one collider in it. So let's create an if statement that says if the colliders.length, so the length of the array, is greater than 0, then we're grounded. Doesn't matter if we're touching 1, 2, 3, 4, 5 colliders, we are grounded. This is handy because, as we've seen before, to create a jump function for characters, we will use grounded to determine when we can and can't jump. We also, at the same time, want to be searching through this array for any objects tagged as a platform. For that, we will create a for each loop. In the brackets for each variable, we will call collider. In the colliders array, we're going to look for a tag. And we do this using another if statement. If the collider.tag is equal to, and you can use any name you want here, I'm using moving plat, then we want to parent the player to that platform and make it a child of the platform. Therefore, the transform.parent of the player will equal that of the moving platform's collider.transform. When we're not on a moving platform anymore, we no longer want to be parented to it, so we'll say else the transform.parent of the player equals null. Then, at the end of it all, if we're not grounded, we're not on a platform, we no longer want to be grounded, else grounded equals false. There we go. Now, before we head back into Unity, we won't be able to see this ground checker in the engine, so let's have a go at drawing a gizmo for it. To do this, let's create another void called void onDrawGizmos. This is going to allow us to visualize the ground checker in the engine. We want to give it a color, so we'll say that the gizmos.color equals color.red, or whichever color you like. We also want to give it a shape. As it's a circle, we will use gizmos.drawWireSphere. In the brackets, we want to assign the ground detector's position and the radius. And that's all we need to do. Before we head back into Unity, do make sure to add the ground detector method in your fixed update like so. And when you're ready, let's hit save and head back into Unity. Now it's time for the final setup. In the player controller script, you can see we have the ball for grounded, the layer it's asking for of ground, the ground detector, and the ground radius. Select your ground detector, pop it in there like so. Let's give it a radius of 0.5, and there you can see that the gizmo allows us to see it in the scene. As for the ground layer, you will need to create that layer in the layer tabs down here, where it says default, select the arrows, add layer, and you can create your ground layer like so. So make sure that the ground layer is assigned appropriately. Then, on the platforms, we want to make sure they are also on that ground layer, along with anything else in your level. So I have my several platforms here. So these are also assigned as ground, whatever you want the player to walk on. And we want to give the platforms that tag. So like we created the layer, go ahead, add tag, and create your tag. The spelling does have to match that which we wrote in the script, so do be careful. I will also remove that parent to platform script. That was just to show you some problems that can occur. When you're ready, hit play. And the first thing you'll notice is because we're on the ground layer, grounded is true. Now, when we move onto the platform, we should only be parented to it when we touch the top surface because our ground checker, our ground detector is overlapping with it. Let's make sure we don't get stuck to the side of this platform here. Excellent. So this is more accurate and much cleaner. Let's make our way to the top. Fantastic. You'll notice when we're not colliding with the ground, grounded is false. So you can use this then to control other functions such as jumping or whatever you'd like. And there we go. One simple way to create vertical and horizontal moving platforms using sine waves, and how to create a more accurate, much cleaner platform and ground detection. If there's any other platforms you'd like to know how to make, please let me know in the comments here or on our Twitter and Instagram. Your suggestions for future videos have been great so far. Please do keep them coming. I will work hard to get through as many of them as I can. Until then, thank you all very much for watching, guys. I will see you soon.